Welcome everybody. I'm Matteo Faccio, HiRef Product Manager Director, and together with my colleague Fabio Poletto, the R&D Department Director, we are going to talk to you about data center sustainability. We will explain you how we can increase sustainability by changing perspective. We won't focus anymore only on the cooling production, but we will consider the heat rejection management. I leave the word to Fabio that is going to show you the data center impact under the environmental point of view.
Thank you, Matteo, for the introduction. As we know, the data center infrastructure has a huge impact on the energy demand. It's estimated that more or less the 1% of the global energy demand is dedicated to the big infrastructure of data centers. This is equivalent to 200 terawatts per hour of consumed energy. And on the environmental point of view, this is estimated about 191 megatons of CO2 emission in the atmosphere. Considering the fact that this need of data center is increasing due to the traffic that is increasing by the 61%, and also to the prevision that Frost & Sullivan has made about the global investments on data center market that will grow, will have a growth rate more or less of the 10% per year, we understand how urgent is to give more sustainability to this kind of infrastructure.
Okay, Fabio. So which technical aspect shall we consider in order to have a wider view on data center, not only considering the cooling, but also considering the heat production and the heat rejection?
Yes, there are some technical aspects that we have to consider. For sure, we have to think about modern data center where there are inside the containment system that is able to separate the cold side from the hot side. And this gives the possibility to increase the temperature outside from the devices, and that is coming to the cooling devices. And also that is in combination with the higher temperature that the ASHRAE recommendation is giving for the possibility to use to supply the servers. Another aspect is related to the diffusion of the liquid cooling system that is coming more and more interesting for the market, especially for the high performance computer. We have to think about the direct cooling system, direct to chip cooling system that is shown on the left side, but also to the immersion cooling system that is possible to make with a single phase or double phase. All this kind of liquid cooling system give the possibility to increase the power density that we have for each rack up to 100 kilowatts per rack. And also the increasing of the computational capacity, reducing the dimension of the rooms where we have to install the servers and of the data set in itself. This is an important view for the investors because it's reducing the costs of the data center itself in the investment and also in the operating costs. But from our point of view, this means that we have an increasing of the temperature that we have on the dissipation side. And as first, this increasing of temperature give the possibility to create efficiency on the cooling systems because it's easier to make free cooling. For sure, we know that there is a lot of possibility of free cooling with different devices. For example, with the air-to-air indirect free cooling that is also integrated by adiabatic system, or with the free cooling chillers that has integrated the free cooling on board, or the direct to chip liquid cooling that is connected to the big dry cooler outside. But all this kind of systems and all the free cooling system is generating heat that is rejected to the atmosphere because all the heat that we are giving to the atmosphere is think about a waste of heat.
Okay, Fabio. We understood that we have a lot of heat generation from data center, and we normally are dissipating, we are wasting it using dry coolers, remote condenser, cooling towers, chillers, all the type of different external units normally we are using. Which possibility can we implement in order to capture this heat and to reuse it?
As first, we have to think about which type of heat we have from the data center and for the application, because in general, when we are thinking about the heat recovery system, we have in mind the high temperature heat recovery. For example, what is coming from the electricity production or from exhaust combustion or steam generation or other industrial process where we have a temperature higher than 100 degrees. What is coming from data center is and at lower temperature, for example, at 50 degrees if we are discussing about liquid cooling, or between 20 and 40 degrees if we have a standard air-cooled system. It's difficult to use this kind of heat rejection in a direct way. So the best way, in our opinion, is to combine this with a heat pump. And water-to-water heat pump is the right device that is able to increase the temperature using as a source the data center heat rejection that could be at 50 degrees, for example, and increasing this temperature up to 90 degrees for the combination of other applications. For sure, the heat pump needs to be an high COP for the correct use of the electrical energy. This is possible for the modern heat pump due to the optimization of the operating maps of the compressor that, in comparison to the past, is possible to work with very high evaporating temperature and also with the higher condensing temperature. This is considering also the application of new generation of refrigerant that, thanks to the F-gas regulation that give us the possibility to reduce the GWP, we need to use this low pressure refrigerant with very low global warming potential. For example, 6 for the R123 for ZE, or 299 for the 515B.
So we understood that we need an heat pump. This heat pump is going to increase the temperature level of the waste heat from the data center and making it more suitable for other type of application. Can you make some example of heat reuse destinations?
Yes, of course. As first, we have to think about the surrounding user. We have example in the north part of Europe where the new urbanization plan give the possibility to build up new data center only if there is the possibility to supply the heat rejection to the neighbors. The possible application are for sure the swimming pools or the sports centers, but also the hospitals or the laundries or other industrial process like, for example, the food drying. All this application requires a lot of heat all over the year and can have benefit from the data center heat rejection. Other application where it's possible to use the heat also in a direct way are the agriculture, where we have, for example, the greenhouses where it's possible to increase the temperature all over the year and increasing the production of vegetables, but also the vertical farms. The vertical farms are becoming more and more popular in the market because is reducing a lot the supply chain of the fresh vegetables. In general, they are co-located near the cities, where is also the ideal position for data centers. So is very close to supply the heat to this infrastructure. Another ideal application for the data center heat rejection are for sure the district heating network. But in this case, we have to think about only to new generation of district heating networks, because if we look to the design of the past, in the beginning of the past century, we have that the network was supplied with more than 100 degrees. And in this case, is not useful for the heat rejection from data center. But with the new generation of network, where we have a decreasing of temperature and increasing of the efficiency of the distribution, the temperature is going down to 50 degrees, and the connection to the data center with the heat pump is ideal for supplying a lot of potential users. A further step for the sustainability is the use of the 5th generation of district heating. This kind of network is made with a double loop where all the elements can be connected with a bidirectional flow. This network works with a very low temperature down to 30 degrees. And here the data center can be connected in a direct way, taking the cooling energy from the net and rejecting directly the heating in that. Also, other processes are connected as a source to the network, like the industrial process that has a surplus of energy. Also, the other sources possible, like the river or the sea or the grey water heat recovery. An important role has also the aquifer, where it is possible to storage energy during the summer for the next season. All the possible users of this network is represented by the swimming pools or the space heating and cooling by the commercial buildings, offices, or residential buildings by the use of locally heat pump installed. The network needs an energy hub that is used for the balancing of cooling and heating demand. The estimation that the University of Hakem has made about the saving of this kind of network is about a reduction of the cost by the 42% a year, and the reduction of the total emission by the 56% compared to the standalone systems.
So looking at this last slide, we can see a lot of new possible partners in this type of business. And of course, it's also possible and easy to imagine new business model for data center owner that can take benefit of this waste heat that normally they were dissipating, and now they can maybe sell to somebody else and get money for it. But by the way, talking back to performance, so can we consider still the PUE like the unique factor to evaluate the data center performance, or shall we consider something else?
So this is a good question, because we know that up to now the main KPI used for evaluating and compare data center is the PUE. But this parameter is taking care only about the efficiency of using of energy inside the data center. And is not considering the fact that we have a potential reuse of heating. What was proposed by the Aalto University is to consider two new parameters, two new KPIs. The first one is the ERE, that is energy reuse effectiveness, that is considering the possibility to deduct from the total energy consumption the quote that we are able to reuse, for example, selling in the network. The other one is the HiRef, that is the energy reuse factor, that is considering the ratio between the reused energy and the total energy consumed by the data center. So this is very important because it's changing completely the metric where we are evaluating data center, considering the potential and the benefits that we have for the community in case of reuse of the heat rejection. For this aspect, if we want to go for the carbon neutrality and more sustainability, we have to activate this process. And it's not possible to do it without new kind of regulation, with tighter regulation. We have an example, for example, in Norway and in Finland, where they are reconsidering the data center as a thermal energy producer. In this way, is changing completely the mindset for the data center owner that has a new possibility to get money and activate this process for the sustainability.
This is really interesting. Up to now, we simply talked about theory. We understood how we can increase the level of the temperature of the waste heat of data center in order to make reusable for other application. But do you have some real example in Europe of this type of application?
Yes, of course. The first example is the Telia data center in Finland, where the heat rejection of the data center is able to cover the demand of 20,000 residents through the network of the district heating of Helen. In this case, there is also the reduction of the taxes for the electrical energy consumed by the heat pumps. Another important information to know is that the Helen district heating has the target to reach the carbon neutrality by the 2035. The second example is the Ericsson data center in the south part of Finland that is able to reject the 15,000 megawatt of waste heat to the network, covering the 20% of the annual demand by the district heating. Another important example is the Apple data center in Viborg in Denmark, where is able to reject 55 megawatts of surplus energy that is generated at 30 degrees, and with the heat pumps is boosted in temperature up to 50 degrees to supply the neighbors community. The last example that we want to show you is the North Sea data center in Netherlands, in Eindhoven. This is an example of the 5th generation of the district heating network, where there is the possibility to cover the needs of cooling of the data center with the network and reject it at the same time the heating to the net. So going to the conclusion of this presentation, we can say that the way for the sustainability has to pass through the heat recovery and the integration with the smart grid of the city of the future. We need for sure an heat pump, and that will have an important role for increasing the temperature and enlarge the possible application. For sure, we need a new metrics to evaluate the data center performance and has the possibility to boost this market, and together with the new regulation that has to come with the incentives to start this way to the sustainability.
Okay, thank you. Thank you very much, Fabio. Thank you for your explanation. So I think that everybody of us understood that it's time to see data center not only like energy user, but also like energy producer. So we are ready for this change, and now it's your turn to start thinking in this way. So thank you very much for everybody. Thank you for your time, and see you in the next speech.